We have also we will have then also like a short demo just to introduce you to Betrel reservoir engineering tool. So let's start with the presentation. The agenda will be very simple, actually, just Betrel interface and then pre and post simulation. Then I will take you to the uncertainty and optimization for the history matching and the prediction workflow. Then also I will introduce you to some of our guided workflows and the plugins have been built in Betrel to help the reservoir engineers in the work. As you can see here in the screen, actually, the Betrel user interface is a little bit, I would not say it's complicated, but we can say it's like a very detailed, right? That's why we are like divided Betrel into three main parts, which is the Windows display, as we can see here. Here, actually, we can see all of the 3D, 2D, and results windows. Whatever process you would like to do, you can see that in the display window. Then also we have up here, as we can see, we have some of the ribbons, and those ribbons actually will depend on the perspective. Everything will be very clear, I think, when we have our demo. And then the third main part is this part here, which called the Explorer panes, because we can see our input, our cases, and the processes we are, the properties we are handling with these cases. I will not go in detail for this one because, as I said, I think it's a little bit boring here, but maybe in Betrel it will be more obvious. This part here as well is just to show you that for each perspective, we have like a lot of ribbons, right? And for you as a reservoir engineers or for maybe a geoscientists, we can see that we have we divided Betrel into some of the categories, such as this one here, for example. We can import and build a new simulation grid. And then also you can build your fluid, you can build your rock, and you can put your aquifer. I mean, it's a little bit straightforward. It's in a way how you are building your model. So if you go through this from the left to the right, you can see that it's a little bit it's obvious, right? It's not complicated, but we have a lot of icons because we are handling a lot of processes in this window. You as a reservoir engineer, as a petroleum engineer, you need to build your model, and then you need to introduce your wells, right? That's why you can see also we have the well engineering tool here. So you can build your wells by your hand, I mean manually or automatically. It's a very also straightforward and a very detailed processes, which is very useful for the petroleum engineers. Then also at the list here, you can see that we have some strategies just to link those wells with your reservoir, because after you created here your properties, right? And then you have your aquifer, you have your functions of the fluid and of the rock. You have your wells here, and then you need to connect everything together just to start producing or injecting or enhancing your recovery. That's why you need some strategies, and we have two strategies actually mainly in Betrel, which are the development strategy and the field management strategy. I think I will go in details a little bit for those two because they are the most important engines actually in Betrel as Betrelari. Then also here you can add your defined simulation case. Actually, this is the main thing for you as an engineer, because here you can put your properties, you can put your rock, you can put your fluid and the wells together with the strategy in this tool here, which is defined simulation case. And last but not least, here we can see that this is the post-processing, or this is the advanced thing, right? Because we can, after I build my case, now I would like to make some history matching, or I would like to make some prediction for the future. How much can I produce, or what can I enhance, right? In order to get my NPV very high, or the oil production rate, for example, high. So I need to activate this uncertainty and optimization tool, and then I can work on that to find my results for prediction and for history matching. I added this one actually, but just to show you that we have in Betrel, I will introduce that as well. We have some simulators, which called Eclipse, Betrel. We have Visage. I mean, we have a lot of simulators, but I think you heard about Eclipse in Betrel. And now we have also Intersect, which is the new version, let's say, of Eclipse. And now we are encouraging all of our clients just to go in this direction of Intersect. That's why we added this button here, where you can convert your Eclipse into Betrel, and then you can convert that into Intersect case. There, actually, you can get the advantage of Intersect. I will not spend long time for that because I think we don't have a lot of time. We added this slide here just to show you that Betrel actually is an integrated platform which will connect everything together. Every domain can work with other domains in this platform in one project or in one platform from the exploration until you reach the production. So you can start here building your you can start building your 2D seismic, 3D seismic, and then you can put your appraisal wells. Then you can also put your development wells until you reach the production wells. And for the seismic, everything will be just in one software or in one platform. Betrel, I think we just celebrated the 25th day for Betrel last years, and this is just like a roadmap for Betrel until we reach 24 here, where we added machine learning, and of course until now this one has been developed, I mean, in a very beauty way. We introduced agile reservoir modeling. I saw you that in the introduction, which is called ARM, which is agile reservoir modeling. Which is actually, you can use now Betrel not only in your machine, not only in your computer, on-prem code, but you can now use it in Delphi, which is our cloud. That's why, I mean, you can now run a very huge, very complicated model and you can get the advantage of the computational power of our cloud, which is called Delphi. I mean, we have a lot of things. What we introduced is the AI, artificial intelligence, and machine learning to help you in your processes in Betrel. Here as well, just to show you that we are connecting everything from the Bayesian model, right? Because here you are, if you have like a very huge and large field, you don't want to go to take everything, but you can start like studying your geological interpretation until you reach the reservoir modeling. Then also you can add the geomechanics until you reach injection and production for the reservoir engineering. And then you can connect your Betrel, and you can connect now your subsurface with the surface. By the management, as I said, right, we have the field management and we have development strategy, and this is the loop actually Betrel is helping the engineers. Betrel, as I mentioned, we have some simulators like Eclipse, Intersect, Visage, etc. We have a lot of simulators that are included actually in Betrel as a platform, but also Betrel can be also connected with other SLB or Schlumberger products such as IEM and MIPO Fluid Modeler. Where you can also, like, if you don't have this software inside your Betrel, you can connect that very easily with Betrel, and this will make the toolkit, let's say, is very smooth. I hope I'm not very fast, but I would like just to cover as much as possible. Delphi, as mentioned, this is our cloud now. You can put everything you can see here in cloud, and you can get the advantage of the computational power. Betrel reservoir engineering, actually here in Betrel in general, right, you can do whatever you want in the reservoir engineering or in geoscience engineering, let's say, from the pre and post processing, where you can start working on your properties, the permeability, porosity, whatever you want, and then you can also see the results in this charting window or in the 3D window or in 2D window or whatever visualization tool we have. So that's why we said it's like a pre and post processing. Then also you can, after you have your properties, you can now connect that with your reservoir simulation, Intersect or Eclipse, in order to start the flow, right? Because now you have the properties and we would like to see the flow now in this reservoir. So you can now choose which simulator would you like to use. And after you are satisfied with your case, now you would like to start your history matching by comparing your results with the observed data you are gathering from the field. And here, actually, you can also put that in the uncertainty and optimization tool, where you can make your history matching. And of course, also after you finish your history matching, you can start now your prediction. For, let's say, for example, I would like to predict the behavior of my reservoir for the coming 20 years or 30 years or whatever. Of course, also maybe for the CO2, you can make that for thousands of years, right? Because I would like to see my CO2 plume expanding for the boundaries of my reservoir, which is very important actually for the companies and for the governments right now, just to see if we have any escape in the CO2. And you can do that for thousands of years in petrel. After you finish your uncertainty and optimization for history matching and prediction, you can also visualize your result in Betrayal, and you can then pick up what is the best scenario for me and where I can now start. I can choose my case, and then I can use this case. This is just like a short demo to show you that we have something called streamlines. As you can see here, those lines actually, which are the lines between the injectors and the producers. I have those wells, right? Those wells, some of them are injectors, some of them are producers. And here I can start injection, and I can see now the fluid is going from this well to this well, for example, and I can see what are the affected wells if I have some faults, for example, or whatever I have. I mean, this is a very nice tool where you can now control your flow. As you can see here, we have some points. That's just indicator that the water, or the fluid is going from this well to this well through this streamline. It's a very nice tool, and it's very useful. In this simulation here, we can see also the charting window where we can see our field results, right? And also you can now dive inside the wells one by one, and you can see, for example, when I use this case, now I have this matching, as you can see here. Those are my observed data, and this line, the green line, is my case, right? So I can see also all of the wells, which wells are nice, which wells are not that nice, right? So maybe I need to work on those wells just to make the history matching more accurate. Okay, now let's start with Betrayal as a workflow. I mean, we can start from building our simulation case, right? Now, after when Alex will speak, he will mention also something about the properties. So after Alex finish his properties for like porosity, permeability, net to gross, I need those properties to be included in my simulation case. After I finish my simulation case, I will execute and I will visualize the results. Then I can see the uncertainty management and history matching. I will not go in deep on those slides, because in the demo, I think it will be better for you. I know that maybe it's boring now just to see some slides and some pictures, which is, I know that it's not the best way, but I will try to cover like some of those things here. To build actually the model, as I said, now we need the porosity, we need the permeability, right? And then also I need to start introducing the rock to my model, because we know that the reservoir is a combination between the rocks and the fluids, right? So for the rocks, for example, I need now to start building my rock, where I can introduce the rate permeability, I can introduce the capillary pressure, and then I have the compaction of those rocks, the adsorption, and also the G function. Betrayal will help you actually also, like, it's very straightforward. You can see here, for example, when I open this window, I can see I do that also in the demo. We have the make rock physics function, where we can click on the use preset if I don't have data, right? Maybe some of you are like students, and maybe you would like to do your bachelor or master thesis using Betrayal just to do some experiments, and you don't have maybe a real data. Betrayal actually will help you to overcome every barrier in that, and you can just click on use a preset. You have this list, and this will provide you with a predefined sets of data. So you can create your rock here, or if you have your data ready, you can introduce your data directly to this window. Of course, you can even create your data if you have the data, as I said, right? If you have the query numbers, for example, if you have the rate permeabilities, if you have the saturations, you can put everything here. Or if you would like, also you can work with the capillary pressure, or also you can go through the G function. I think those terminologies you are familiar with those things, because as petroleum engineers or like students, I think you heard about them. But here now you can apply them directly, and you can make that like in the hands-on. After I finished my rock, now I would like to introduce the fluid to this reservoir. And we know that we have maybe black oil model, or we have the compositional model, right? Petrol also will allow you to create your model if you have the data. As I said, you can introduce your data. If you don't have the data, also you have the preset, as we can see here. Also, you can click and preset, and then you can choose the dead oil, for example, or like gas reservoir, oil reservoir, or whatever you would like to have. You can do that, and you will get the data also ready for you. As I said, if you remember in the first slides, I mentioned that Betrel has some softwares, right, or like simulators, such as Eclipse, Intersect, and we said also we have something called Fluid Modeler. This Fluid Modeler actually is very useful for the in petroleum engineering in general, where you can handle your fluid. Because I got my sample, for example, from the field, and now I need to make some experiments, right, or like some tests on my fluid, just to be sure that those are my data. So after you finish your solubility test, for example, or whatever test you are doing, you can then export this fluid model from the fluid modeler, and you can import that directly into Betrel, or you can build that directly in Betrel, as I said, since maybe you don't have real data. Next step, actually, after I have my rock now done, I have now my fluid done, I have my properties from Alex also done. Now I would like to start drilling, right? So I need to introduce now some wells to start injection or production. Betrel will help you also to do everything just in one click, right? Or if you would like to make it very detailed, you can do that also in Betrel. It will allow you also to make some like the vertical wells, deviation wells, or if you have also like some horizontal wells, everything is possible, and you can do that even manually or automatically. After I introduce my wells, I would like now to control my wells, because maybe I would like to start perforation, right? Because now I have my wells in the reservoir, but I would like to start flowing, right? So I have now the fluid inside my reservoir. I would like now to start a dragging or injection. So I need to know where is my well penetrating in this reservoir. So you can see this intersection here. You can see now this well, for example, is penetrating in this water zone here, or maybe in this oil or gas zone here, right? So I can now know where should I put my perforation to start injection or to start the production. In the well section as well here, you can see those are the layers, right? I mean, everything here you can see, it just like will help you to understand where is your well penetrating and what you can do in those areas for the history matching and for the prediction. We have something called well section window. Those are my wells, as you can see here, right? This is the casing, and I can add in this window my porosity, my permeability, my saturation, right? The oil saturation, water saturation, and then I can decide, for example, when I have this layer, for example, I have some oil, right? So I want to put my perforation, as you can see here. We have a lot of tools actually in Betrel, which is very easy to use. I can just click, I would like to have this perforation in this area here. Just I can click here and it will be automatically created for me. Of course, now we have a lot of machine learning tools which will help you actually to put all of those wells, and it will build for you the wells, it will build for you the perforations, and I think it's a very advanced thing. And maybe if we have any other session, maybe we can go through that. Now I have my wells, I have my fluid, I have my rock, and I have my properties. Now I would like to make my strategy, right? I would like to introduce everything to each other. I would like to connect everything to each other. This will be done using the strategy, even the development strategy or the field management strategy. What is the difference between both of them? Development strategy actually can be used for Eclipse and for Intersect. This is our old version, let's say, of the tools or of the engines of the field management. But now we are now having the new FM, what's called the field management strategy, and this can be used only for Intersect simulator. this intersect actually now it's our new version, it's our new generation, and we are, as I said, right, we are now just like encouraging our clients or our users just to go through this way, because intersect is more powerful and it's more accurate, right? Uh, Intersect can use both of them, development strategy and field management strategy. I will not go through details because I know maybe it's a bit boring, but I would like just let you know that we have a lot of possibilities in Betrel, in Eclipse and Intersect, where you can build your, let's say, limitations. For example, I would like to have, for example, the water cut. If the well is more than 70%, I would like to close those wells. If I have, for example, the oil more than 1,000 cubic meter per day, for example, my facilities will not allow me to have such amount of oil. That's why I would like to have a balance, right? So maybe I can introduce the guide rate balance for this field. Everything can be done in FM or in development strategy. The development strategy, I said, this is, can be used for Eclipse, for Intersect, and for front sim. It depends actually on the rules. So we have some predefined rules, and we have some templates where we can say, for example, I would like, as I said, this is my limit for oil, this is my limitation for gas, and this is my limitation for water, right? I can introduce everything, and then I can also use some keywords. So if I would like to have some limitations by myself, right, I can also introduce those constraints by my hand. Field management, this is also the new version, as I said, right? The beauty is this, for this tool actually, is that you can do everything in templates. So you don't have to start searching and digging. Everything is just packaged for you in those templates, as we can see here. I think also I can do that now in the demo if I still have time. So it's very straightforward, it's very advanced, and of course also for you guys, I think now in the new generation you are very familiar with Python. So if you are familiar with Python, you can also make your life more easier, because you can build your scenario, you can build now your code, and you can introduce this code to Intersect by the user edit, as you can see here. This is just a demo to show you the FM. It will not take long time. Let me just take the voice. As you can see here, guys, right? Those are my wells, and those are my groups. For example, I will start from the field. Then I have some injectors and producers. And those wells, I can see that I have, those are the names. This is the type of my well. And here I have some constraints, for example, the bottom hole pressure and the production. This is the field management. I will have my wells inside this field management, and it will let you know that you have maybe some observed data. All of them will be introduced, and then you can start working on the templates, right? Because, for example, now, as I said, I have limitation for maybe 15,000 cubic meter per day in my surface, right? I don't want to produce more than this value or this amount. That's why you can add what's called the group control or guide rate balance. I would add 15,000. Now, when you click apply and when you run your case, it will not produce more than 15,000, and it will let you know which well is producing and which well is not producing. Now, now after I produce this amount of fluid, now I need maybe to start injection, right? Because you know in the field we have a power, right? So maybe it will start producing by itself because now it has some energy. But maybe after a couple of years, I don't have that energy. That's why I need now to start injecting some water. And it's very easy actually also in Intersect or in Betrel now as an interface. It's very easy because now I can choose this tablet to be like the group voidage replacement. What does that mean? If I'm producing, for example, like 1 million barrel per day or 1,000 barrel per day, whatever, I can now re-inject water, right? The same amount. If I put one here, it will inject exactly the same production amount, or it's more logical actually maybe to inject 90%, right? Because some the convergence errors. So here I just said that I would like to inject now 90% of the produced amount as a water. It's done, right? Last thing I would like to show you here maybe, which is the closing wells. Okay, this is a little bit advanced. Let's jump. Yeah, here. So now I would like, for example, here to close the wells who are producing more than 60%. I'm still clicking here. Okay, no worries. Here, for example, I have those production wells, right? So those are producers. I am now producing after some period of time. I started to produce a lot of water, right? So now I would like to say, no, I don't want to produce those waters. So please close all of the wells who are producing more than 60%. It's done. Just like you can choose this template here, which will close everything. As you can see here, max is 60%. Any well will produce more than 60%, please close this one. The next step now, after I build my FM, or like field management, I have everything now done. Now I can start execution and visualization. This is my defined simulation case. We have the grid here, as I said, right? Because we will inherit those properties from Alex, from the geologist team, and then I will start also putting my, or like I would choose my software or like simulator, right? As I said, we have Eclipse 100, which is the black oil model. We have Eclipse 300 if I have compositional model, and we have Intersect. Intersect actually is doing both of them. When I have my defined simulation case, I introduced my properties, then I can jump to the functions here. As we can see in functions, I would like to put now, to connect everything, as I said, I will put now my relative permeability, the rock, and then I will put also my fluid. The next step will be to introduce the strategy, which is the field management strategy. We spoke about that here, right? I will put this field management strategy inside my defined simulation case, and then when I click run, this one here, it will connect everything together and it will start solving those equations between the for the flow. Okay, this is very fast. I will not spend time here because I will show you that in interface. You can see the results for the field, for the wells, for the groups as well. And then also you can see, for example, I don't want to have, for example, the wells producing more than 60%. You can see that here as well. You can export everything here as pictures, as a data in Eclipse, in Excel, and also you can take very like easily the screenshot from here. In 3D results, you can see now this is my reservoir as a 3D, right? I can now move my reservoir. I can see whatever I would like to see. You can make like a cut of this reservoir. And if you remember in the first slides as well, in the well section window or in the well visualization, you can see now my well is penetrating those cells, and you can now follow up with those intersections. Okay. I hope we still have some time. Now for the uncertainty and optimization, after I build my model, right, I have now my case is ready. Maybe it will take some time just to finish running, and then I can take this case and put this case in the uncertainty and optimization. Why I need to do that? If I need to make my history matching, for example, I need to start choosing some variables to be my sensitivity variables, right? And then when I know what are the most sensitive variables for me, for example, let's say the permeability, right? It's a very sensitive one. The water contact in the reservoir, I know maybe it's a little bit uncertain, right? So if I say, for example, that in the depth of 2,000 meters, I have my gas or I have my oil water contact, but if this is still uncertain, so maybe I can say, okay, for the simulator, please take this as a variable and start make some sensitivity. If this, for example, this contact between the oil and water is a little bit maybe shallower or deeper, it will let you know what is the effect of this variable on your results. You can choose actually like hundreds of variables, and you can introduce everything to the software. It will then, after like maybe hundreds of runs, it will let you know what are the most sensitive variables, and then you can handle that. I will show you maybe also that here. The first step actually to build your case, I think we mentioned that if we have Eclipse or Intersect, we build our case. As you can see here, this is the case, and now in the demo you can see that. And then I will introduce my parameters. Those are my variables, right? Maybe the query number, for example, is also can be used as a variable. The fault transmissibility, maybe this fault is open or not open. All of them are uncertain parameters, so I can take all of them. Then I will introduce the start value for that. What are the limitation, the minimum and maximum for this limitation, and then I can put also the distribution method for that. Then, as I said, right, maybe I have maybe couple of hundreds, or maybe like tens of runs. Then it will let you know that those are the most sensitive parameters in your reservoir, and then you can put a cutoff to keep those non-effective parameters out, because it will make the run time larger. Like if you have a lot of parameters, it means that you have a lot of equations to solve. That's why we need to reduce those variables, because they are not effective and not important for my model. So I'll keep only those variables or those parameters. Then I can now go to the next step, which is the Monte Carlo simulations. For the uncertainty, I can say, for example, I would like to take this one as a B10, B50, B90, and then I will put that again as my cases, right? So now I can say, for example, as a dynamic case, I have now B10, I have B50, I have B90, or maybe you have another terminology, which is the low, mid, high. And then I can go to the management. I will tell them, okay, hello guys, now those are my cases. I have B10, maybe will produce for me, for example, like 1 million barrel per day, and the maximum possibility or like potential for this reservoir is I can maybe produce 1 million point 2, right? And then you can maybe take the decision. I would like to start using the B50 case, and this will be my start point for the prediction. This slide, I just like have it just to show you that also in the uncertainty and optimization, as I said, right, this will be used, guys, for the history matching and for prediction. I can take the optimization. We have something called objective function, and we have a lot of optimizers, as you can see here. Those optimizers will let you know that, for example, I would like in the history matching, right, I would like to make the difference between my lines, right, between, for example, let's say between my pressure for this well and for the observed data, because I have some data from the field, right? I would say now I would like to reduce this differences between my case and between the observed data. This will let you know that, okay, after maybe like a couple of tens or hundreds of realizations, which means cases, right? Now I know that those are the best ranges for this variable, and now I can move from the local optimization to the global optimization. I can optimize now my case, and then I can get the best case to match my observed data. After that, I can also move to the prediction, because I would like to predict, like after 20 years, for example, what is my NPV, net present value, what is my production rate, what is my cumulative oil rate, right, or cumulative oil production. Everything can be done also, but now you need to make it vice versa. Instead of reducing the objective function, now I would like to make it increasing, right? So now I would like to introduce, or I would like to know now which case has the highest objective function, which means like here, for example, right, I have the NPV, the blue line, maybe this is the lowest one, but maybe the objective function between both red and the blue is the highest. So I will take this case as my best case for the prediction. I hope it's clear. Then after we finished maybe the history matching here, in this case, now I would like to see my results. As we can see, let me just make it a little bit zoom in. Okay, those are the green dots here. Those are my history data. I gather those data from the field. Now I make some cases, right? This is my base case. When I build the case, this is my base case. And then after I run maybe tens or hundreds of cases or realizations using my using the uncertainty and optimization, then I can see that this is the calibrated case, and I can see now the matching is very nice, right? Okay, grid property modifiers, I will not go through that, but just to let you know that you can take just a small part of your reservoir and you can enhance this part. Okay, okay, this is the last part in my presentation, which is the guided workflows. We have a lot of guided workflows, because we know now that it's a little bit very huge, right? But we can have, for example, like for the CO2 storage guided, we know that a lot of companies now are focusing on the CO2 storage, and you can use this as a pre-built workflow. We can have that. Just put your data and click generate. It will create the case for you, and then you can see the results in the charting window. And the beauty of this software actually, that you can see the bloom, as you can see here, right? Maybe I can see after 1,000 years, where is the spreading of this bloom in my reservoir? Okay. Yeah, thank you for that. I don't know if I still have time for demo or not. Osei and
Yes, Lord. You have time for demo.
okay. I will make it also a little bit short, and just stop me, right? If I take longer time, just stop me. And guys, if you have any question, please just raise your hand or open your mic, and you can interrupt me. No problem for that. Okay. Just please let me know when you see my screen. I think now you can see my screen, right?
Yes.
Okay. Thank you, Osei. Okay. For this demo, guys, I would like to show you also one of our plugins. So let me take everything out. I don't want to see anything in my Betrayal. Okay, just for you, maybe for some of the students, as I said, since you are now in the university, or maybe also if you are professionals and you are using maybe Betrayal. Okay, now I want to make some tests in Betrayal, or maybe I have like some ideas to test, right, for enhanced oil recovery, for example, or for the water flooding. I think you have this project at the university, and I want now to build my model. I don't have time to start like making everything from scratch. That's why you can just go, when you open your Betrayal, you can go to the simulation, right? I mean, maybe it's a good idea also to go through those the ribbon. This is the reservoir engineering, as I said, right? We have the well engineering. Those are the tools for the well path. I can build my fluid here. I can build my FM, the field management strategy and development strategy. In the simulation, this is my area here to start working with my defined simulation case. And here, those are the charting window. I think now if you remember anything from the slide, the pictures, you can know that those are what we are speaking about. And in the home here, this is the perspective, and here you can choose. I would like to work, for example, for the reservoir and the production part, or if I am like working with the seismic, whatever you need, drilling, right? You can choose your perspective, and then you will see those are your ribbons, and just to make it easier for you to follow. So now, maybe as a reservoir engineer, I would like to start building my case, right? But I don't have real data. I would like just to test anything very fast. So when I click on the conventional model builder here, I will see this window. And this plugin will help you to build your case from scratch. Okay, you can ignore anything in my screen here. I don't have anything. I would like now to just build my model. Okay. Here I can see, for example, I would like to run my case in my machine here, right? I would like to use intersect. I would like to have only, is this my guys? I think someone is making some lines. Okay, no worries. Then, okay. This plugin will help you to build your model, right? You can put your properties here for porosity, permeability, whatever you want. If you don't want to put anything, don't do anything, right? This is my aim now, actually. I will not change anything. This is the pre-built plugin. Let me name it, for example, SBE conference, right? And relative permeability, if you have any relative permeabilities, you can put that here. If you don't have, just keep it as it. Then also, if you have fluid, if you have any initialization for the fluid, I would like to use, for example, this pattern, the 5-spot pattern. Whatever you want, you can do that here, but I will not do anything, just to show you the easiest of this plugin. When I click generation or generate, it will create now a case for me from scratch. It will create the properties for me. It will create the wells for me. It will create the fluid, and it will create the rock. And then also it will create the field management strategy for me. I did that just to make it very fast, because I think we are running out of time. It's done. Now I can see, I can close this one here because I don't need any more. You can see that this is your case, guys, as BE, right? And we have, this is my model now. It just like build this model. I can increase the number of layers, but I did not do that, just to show you that in one click you can do whatever you want. This is the 5-spot model pattern, right? I have a lot of producers, a lot of injectors. So let's go now just to show you the interface. It builds for me, this is the rock function, right? We can see now I have, this is the compaction. Let me increase this one a little bit. Okay, so I have now, this is the rock compaction. I have the relative permeabilities. I have the capillary pressure. I can convert the capillary pressure to G function, but I will not do that right now. And then also it builds for me the fluid, right? I can see here we have the black oil model. We have the gas, we have oil, we have water, and then I have also the initial condition. Initial condition is very important because it will make it a reference for you for the pressure. Then it will also build the wells for you. As we can see here, I have some oil producers, I have some water injectors. Right, it will build a lot of wells because you can control that, of course. And then I have also my field management, right? This is my field management. I will open it right now, and we can work a little bit on that. And this is advanced thing, which is the user edit, which is something, I mean, very advanced, and you can do that by your hand if you are familiar with Intersect and with Python. This is the field management, guys. I think we saw the demo for that, but here let me show you what we have. This is the start date for my process, right? You can choose to be like months, years, whatever you want. I mean, this is the time step between the convergence steps. And then here also you have the wells introduced, the same wells we had before, right? Those are my producers, those are my injectors. And then we have groups. We package everything in 2 groups, injectors and producers, and all of them will be inside the field. We can see a lot of icons here which are empty because we did not do anything right now. But when I click run now, because this one has been like built by this plugin, when I run this case, this is my generated case, just right click and you can click simulation export and run. I will not do that right now because maybe it will take 2-3 minutes. However, I mean, when you do that, now you are connecting everything together. You are now connecting your properties, your wells, your functions for the fluid and rock, and then you can see now the results in the charting window after it finishes. I think just to show you the one we had, for example, I would like to close some wells when they have water cut more than 60%, right? When I choose this template here, now I would like to choose the producers to be closed. Any producer is producing more than 70%, please just close this well. It's done. Now we have everything ready. For example, I would like to add the guide rate balance, right? Because as I said, my surface facilities is very limited, and I don't have maybe like only, let's say, for the field, right? I have oil production. I can just per day, I can maybe just produce maybe 50,000 barrel per day. That's it. Click apply, and now you have it. I would like to save the same strategy. That's it, right? And then I click apply. Now I will have my strategy ready. I have all of the wells. I have now my condition more than 70%, please close, and I cannot produce in my field more than 15,000 barrel per day. Click OK, and then you can run the case. You can see the results. As I said, now maybe we don't have time to run the case, but I think I have this one. I did it today. Let's go now to the charting window just to show you the visualization tool. Okay, now here I can choose my case. I have this case ready, right? I can see here that I can see maybe the results for the field, for example, right? Or for the groups, because normally I have two groups, the producers and injectors. I have all of the wells right here. Now I would like to see maybe the cumulative oil production, and I would like to see the cumulative water injection, cumulative water production. I would like to see the pressure for my field. I would like to see the water cut for my field, and maybe that's it, right? For now, maybe the gas oil ratio also is a very good thing to see. Click OK. I know that now it's very complicated. You cannot read anything here. That's why you can just split by properties. And you can see now I have every property alone. I would like maybe to split this more windows just to put everything in my vision. Now I can see everything here. Let me just click this one to make it more clear. Right. So I can see, for example, now the pressure is dropping from 300 bars to maybe 50, right? After maybe 8 years or like 1 year, because I don't have a lot of injection power, right? Or energy. I mean, here, this will give you a very clear idea. What would you like to do? And maybe I can move now to the wells. Say, for example, I have now this well, right? I can see that this one is a producer. It is producing only water. So it makes no sense to have this well. I would like to close this well. As I said, maybe I can put more than 70%, it will be closed. This well is very nice because I don't have a lot of water. You can see here, this is the cumulative water is nothing, or no, it's a lot, but also I have some oil producing. This is the water cut, and I can maybe like control everything from here. And of course, also you can see all of the wells together. And this will make maybe sense just to control everything. I don't want to see anything but only the water cut, right? So you can see here, this is the water cut. Yeah, okay, this is only the water cut. But now I need to see only the primary identifier, which is the wells, right? Because I don't want to see the property. I have only one property, which is the water cut. But now I would like to see all the wells together. You can see here that we have for some wells, the water cut is very low, 0.00015. And we have for some wells is maybe 90% or 80%, right? So now I can decide, okay, this well is very bad. This well is very nice. So I will keep this well. I will close this well. Or maybe I will convert this well to be water injector. I mean, this will be based on your strategy and based on your management team. Okay, I think we finished this one here, the input. We can see our input data. Now we have our case here. Okay, let me just go to this one. I think this is the final thing I would like to cover. Here, I think also it will be covered by Alex now. He will tell you that he will build the properties for you, but you can see the properties right here. You can see the, okay, let me show you right here. Okay, right, maybe we have the skeleton here, right? And maybe I will see also my horizons. I can see my properties for the permeability, porosity, for the saturation. And the final thing, it will be just to show you this thing here. I would like to visualize that with the time, for example. So I can choose now the time applier, and we can see now. Okay, I don't have a lot of time steps. I think it was years, so we don't have a lot of them. But however, for normal, actually, if you have like long time, right, you can see that when I started, the pressure, for example, will be very high, and then with the time, it will be low. Okay, maybe I can choose this one. Let's go to the pressure. Okay, for some reason, I don't have the dynamic data right here, maybe because I did not run the case. But however, I mean, you can see with the time, guys, it will be very nice for the presentation or for yourself that, for example, the pressure is just declining or dropping, right? I can see the movement from the injectors to the producers. And I think I have the streamlines right here. Okay, okay. This is the reason. Yeah, however, now, those are my streamlines. Let me open a new window. All right, you can see here now, those are my streamlines between the producers and injectors. Let me also introduce the wells. Right? So those are my wells. As you can see here, guys, we have those lines are streamlines between this is the injector and those are for producers, right? I can see, for example, for this one here, this is an injector, right? And the water I'm injecting here will go only to this well and to this well. So now I can control my wells. For example, this well, okay, it's not useful because when I injecting, I will not get like the potential I would like. But for this well, for example, it's very nice because when I inject here, I can see that I am supporting all of those surrounding wells. But for this well, for example, is not the situation. I mean, this is just like an overview. And of course, when you are like working on that very detailed, you can see that now I can see which one I would like to convert from production to introduction, to injection, sorry, and which one I would like to close, which one I would like maybe to produce more. Thank you so much. I don't want to spend more time for that, and I don't want to make it more boring for you guys. I hope you enjoyed, and if you have any question, please go ahead. Is it possible to convert an intersect case to Eclipse case, or is only the okay? I mean, we don't have a direct way to convert intersect to Eclipse because, as I said, intersect is the new version or a new generation, right? We can do that, but you can do that. I mean, in Betrel itself. Let me show you how to do that very fast as well. Okay. Say, for example, I have this case, right? When I click define simulation case, now I will have my case. And in the same case, when I create a new, okay, just write me, guys, if you can see my screen.
Yes,
Mark?
can see your screen.
Okay, nice, thank you. So for you, Mark, I think you are the one who asked this question. Let's say that I have this one here, right? When I click create a new, now I can give any other name for this new case. Okay, yeah. So I will name it, for example, Eclipse, right? CMP, and then I can choose the simulator. It was intersect, right? This is what I had, and now I can maybe choose Eclipse 300. This will convert the case for you, but of course, there are some steps we need to follow because just the QC, right? When you have it, you will see that this is my Eclipse case. I have everything just exactly what I had in the in intersect, but in the strategy, you will find the strategy empty because as I explained, in intersect, we are using field management, but in Eclipse, you need to choose only development strategy. But if you have Eclipse and you have development strategy, you would like to convert this Eclipse into intersect, you can convert that and you can still using your development strategy. I hope it's not complicated. And what I mean here, this is my intersect case. And when I click on the strategies, I can see that I have here use field management strategies, or I can have also development strategy. So if you are converting from Eclipse to intersect, I think you will have your development strategy ready. So you can just like click here, and then you can insert your development strategy directly to intersect. So intersect is accepting both of them, field management and development strategy, but Eclipse did not. So when I finished here, right, I can see now Eclipse has been generated, but I need now to build my development strategy again. I hope this answers your question, Mark.
Yes, it answers, but the only thing what about some of the keywords compatibility? Sometimes you have a field management strategy, the keywords in the in intercept as against the Eclipse. Sometimes you do it and you're having challenges with some of the keywords, some errors.
Correct. Yes, exactly. Especially the user, the UDQ, right? If you have some user-defined quantities or user-defined what's called we have the user-defined quantities, and we have another thing like the the user-defined tables. It's a little bit hard to do that, but now we are working to make that also more easier. I mean, it will be also like automatically converted. We have something called migrator. I'm not sure if you know that, but we have this tool outside Betrayal. You can migrate, or inside Betrayal also. Let me show you that. And please, guys, if I am like exceeding the time, just let me say stop. Okay. Here, for example, this is the case for Eclipse, and we have something called convert case, right? When I click convert case here, I will convert from Eclipse to intersect with development strategy or with field management, or both of them, right? And then I can say, for example, no, I have E100 or E300. Then you can click convert. It will convert the case from Eclipse to intersect, but you cannot do that vice versa. And as you said, the UDQs or some keywords, you need to follow that by your URI.
Okay, thank you. Thank you.
Welcome. And thanks for your question. Any other question, guys?
Yeah, hello. My other question was the CCUS model, whether it's only limited to intercept or you can also do it in the Eclipse or the CCUS.
No, it will be, honestly, I think only for intersect. I'm not sure, so I will not give you a wrong answer. But I think it's only for intersect because this one here, what I used right now, which is the conventional and unconventional model builder. Unconventional model builder will build for you the unconventional rocks, right? So it will introduce a lot of fractures, but both of them are supporting only intersect, not Eclipse. So I'm not sure, but maybe I can follow up with that.
Okay, thank you.
Thanks. Okay, if there's not any question, so that's it from my side. And stage is yours.
All right. Thank you, Loai. Thank you for the wonderful presentation on the RE side. I'll be taking you through the G&G side of it. So the actual thing is, for the G&G side, we at the end of the day, we supply the data to the RE. That was why Loai during his delivery was mentioning that he gets data from me, from the G&G, mentioning my name several times. I'm going to just take a bit of about 10 to 15 minutes of the time to give a background on the whole reservoir simulation perspective from the G&G side. So I'm going to share my screen now so you have a look at it. When I'm done with the background, I'm going to also look into Petrel to take you through the workflow from the different workflows that we have in Petrel for volume calculation, so that you can have maybe if you are doing something similar, you can always know what to do. Okay, so I'm going to share my screen now. Let me know if you can see my screen. Okay.
Yes, I think we can see now.
Wonderful, wonderful. Okay. So so we're going to go through quickly the whole background of the G&G workflow for reservoir simulation. The idea for the G&G workflow, what we're going to look at is basically structural modeling. We're going to have a look at what Petrel offers within structural modeling, the new tools that are available for structural modeling, and then we're going to do a demo on volume calculation. We're going to have a look at map-based volume calculation. Maybe you've seen it before, but we'll have a look at it, and we'll also have a look at structure for static volume calculations. That is when you have property models or when you don't have property models, you can still go ahead and run your calculations. Okay. So the entire idea for reservoir modeling is just to get a representation of what is on the subsurface. That is, from the GAG point of view, is to get a representation of what is on the subsurface. It's not always the case that we get exactly what is on the subsurface, but at least we want to get a representation of it. It's not going to be exactly what we are going to see. So there's going to be some uncertainty in there that goes to LOI, the RE team, and when they run their simulation, they do run their uncertainty and sensitivity analysis for that. So for the reservoir simulation work, what we want to do is basically, before you start the work, you have to know why you want to do the reservoir simulation. So you need to know the end game, the goal at the end of the day. What do you want? Most of the times it's for volume calculation. And we all know that for volume calculation, right back from the days in our university days, and even if you're still in school, you know from reservoir engineering classes or even from petroleum engineering classes, that you always need this formula to calculate your oil initially in place, right? The same formula goes for the gas initially in place, but the constant changes. Okay, so the main thing here is that we need our volume, we need our bulk volume, and then we need our hydrocarbon pore volume. So once we have these things, we are able to calculate our oil initially in place. So just keep this in mind. The whole work we're going to do, the whole hassle we're going to go through is to get a volume calculation. And that there's the formula that guides it. Okay. For us to do volume calculation, there are certain things that have been introduced to make the work very easy for us. One of them that has been introduced is the ML, the machine learning assisted seismic interpretation. We know that to run a volume calculation, right? If you're a geologist on the call, you know that you always have to do a fault interpretation, and then you always have to do a horizon interpretation. Okay. And this is not an easy task most of the time because you have to go through the several inlines of your seismic and make sure you pick your faults right and make sure you pick your horizons right. So now there have been a tool in Petrol called the machine learning assisted seismic interpretation. I'm going to show you a demo as we go along, but this tool uses convolutional neural network to run the fault interpretation and horizon interpretation for you. So basically, this is an overview of the various structural models we have in Petrel. When in some circumstances, when you're working and you don't have any faults, there is a tool in Petrol that can help you, and that is what we call a simple grid. Maybe you have done that before. I'm sure you have done that before. It is the most common one that is used because in most circumstances, if you don't have any fault within your structure, you can go ahead and use a simple grid. But when you have faults within your structure, the corner point grid system comes in. The corner point grid system can model both normal and reverse faults. And at the end of the day, you need to decide if the goal is to give it to an RE, then there is a checkbox you have to check on to make sure that you run a zigzag corner point model. This allows you, it's more like a stair-stepped corner point model, it makes it easier for the RE to run it in Intersect or Eclipse. The other thing that have been added within Petrol that makes the whole structural modeling process a bit easier is structural framework. We're going to go through it when we're doing the demo. Structural framework, it's more like corner point grading, but just that structural framework it's more automated in a way. It's easier. It goes through it doesn't allow you don't have to go through the hassle of creating pillar grids. And I'll show you what pillar grids are when we go through the slides. You don't have to go through the hassle of creating pillar grids. You just go through, so just clicking on some buttons, running it, and then it builds your structural framework for you. Whether you want to build a depot grid or you want to build a stair-step grid, is dependent on you. Stair-step is mostly done for RE purposes. If you want to run simulation on the model, mostly you want to go with a stair-step. For depot grid, if you want to do extensive GNG analysis, that's geological analysis on your model, then you want to go with a depot grid. Right? So just a picture of how some other things that are within it. This is just a simple grid. There are no faults in there. In some circumstances, you may want to create, refine some sections of your grid, especially near the wall bore. Maybe you want to model a condensate, you want to do an injection, probably CO2. So within Petrol, you can do if it doesn't have faults, you can still do a Tartan grid, which is a type of simple grid. But if it has faults, you can still do it in grid refinement. Then now I'm going to show you the new tool that it's available in Petrol for horizon and fault interpretation. The first of all is fault interpretation. Just a little background on it. Fault interpretation is the idea behind it is to use convolutional neural network to predict where your faults are within your seismic cube. Okay, so you don't have to go ahead and then be interpreting on every inline of your seismic, in every slice of your seismic to find your faults. But then you give it just a few labels. It's a user-trained model, so you give it a few labels and then it can run it for you. We do have a pre-trained model as well that you can just give your seismic to it and then it runs the fault prediction for you. Now I'm going to just show you quickly. There's like a 1-minute video. It's a 1-minute video. Let me just come here. Yep. So this video is showing the process of fault prediction. We just give it our input data, which is the fault, your model. And then you run with certain parameters. You can keep it on default when you're running it. When you click on evaluate or extract, it's going to bring out the faults that is going to predict for you. In this case, we've already run the evaluation process. And we are doing extraction, which is extracting the faults that it has predicted. So what you're seeing here are the different faults that the model has predicted, the convolutional neural network has predicted. And these faults come in point set data. So you can go ahead and then once you're okay with the point set data, you can also go ahead and filter through it. Maybe there are certain things that are there that you don't need them in your faults. So you can go ahead, you have the flexibility to go ahead and then remove them. And once you're okay with what has been predicted, you can just go ahead and create the fault sticks out of it. So once you're okay with it, you just go to the point processing, which is exactly what is going to be done, and you create a fault interpretation. You just run it. You realize that it creates the pillar fault sticks for you, and that you can go ahead and use it in your fault framework and create your fault model, right? Now, the next thing that has also been introduced and quite interesting, in fact, is the horizon interpretation. And this time around, it's not just a single horizon, but then a multi-horizon interpretation. This one also uses convolutional neural network to run it. And this is just a brief sketch on what is happening on the back end. You give it your labels, then it runs it with the convolutional neural network, and it gives you your various predictions for you. Right. So this is also a very short demo, about 1-minute demo on how this is done, you realize that these are the labels, the various blue lines that you're seeing there. You see the labels that have been given. In the yellow ones are also labels, but you're seeing it in the depth slice or time slice. So once you run your model, it predicts the various zones within your horizons for you. You realize that you have a top horizon and a bottom horizon. Between the two horizons are zones. So once you run it, it creates the different zones for you, and you see it nicely as a cube for you. And it also gives you your horizon interpretation as well. So these are some tools that have been introduced to make the process of, so this is the horizon interpretation that it presents to you. And then you can also have your faults in there. So these are some tools that have been introduced to make the process of reservoir simulation from the GNG point of view quite easier. There are other tools like property modeling that have been introduced, but we'll not go deeper into that one too. But that one is also for ML property modeling to make the work easier as well. So at the end of the day, the entire thing, not to bore you so much on it, but the entire workflow for when you get your faults and you want to build a corner point grid, the first thing you want to do is to build your fault model. Once your fault model is okay, you go ahead and then build your pillar grid. So the pillar grid is more like pillars when you're building a house. You have your pillar grid within it, and within the pillar grid, it creates a skeleton for you. So you have three skeletons, one for the base, one for the mid, and one for the top. And within this skeleton serves as the guiding for the top and the guiding mesh for your model. And then you can go ahead and create your zones, your horizons, and your layering. Once everything is okay, then finally you get to have your volume. Remember, at this stage, what we are getting at is getting the bulk volume. Okay. Remember the formula we were looking at, the Stockton oil initially in place formula. What we want to get now is the bulk volume. Okay. In getting the bulk volume, we have to do all of these things. We have to, if it has faults in it, we have to go ahead and then build the various fault models. Here it's more on the pillar grading again, on the process for you to get your pillar grading and to get your layering as well. So once you're done with your pillar grading, you have a volume. Okay. Now you need to get a pore volume. Okay. Before you can get a pore volume, you need to get porosity. And before you can get porosity, you need to get fascias, which is your sediments, your sand, your shale, because it's these sand, shale, and the likes that carry your porosity. All right. And this is the process that we go through in order to run the fascias modeling. We first have to upscale it, and then we go through the geostatistics part of it, and then we go ahead and model it. We're going to go through all of this during the demo session, quickly during the demo session, because we don't have that much time to dive really deeper into them. Right. And there's the same process you go through if you want to do net to gross, permeability, or water saturation. Okay. If you have the logs, you can go ahead and upscale them and go through the same process of modeling. If you don't have the logs, there are some formulas, functions you can get from your petrophysicist, petrophysical functions that help to run these models. Right. So now that you have this, you have a fascist model. That means you've been able to populate your reservoir with your sand, shale, and the likes. Now you need to guide the porosity population as well. You will know that within your grains of your sediment, you do have some spaces in there. These spaces are what house the hydrocarbon. And the connectivity of these spaces are what leads to permeability. Okay, this is why we needed to do our fascist model first and then move on to the permeability and net to gross and saturation. Okay, we're going to use the fascist model to build on the permeability as well. So once you've got your fascist model, you want to do your porosity model, you just have to upscale it and go through the process of data analysis, just QC it, make sure the distribution is all right. Go through the process of data analysis, and then you use your fascist model to constrain it, meaning that you're going to tell it, okay, where you see sand, put higher porosity, where you see shale, put lower porosity, and the likes. And then finally, you're going to get your porosity model. We go through the similar route for permeability as well. Now, at the end of it all, what you want is to calculate volumes. Remember, the formula, we are always working with that formula. The Stoic formula is to calculate volumes. So first, we need to know what our contact is. What is our gas oil contact? What is our oil water contact? We need to create it. Then, once we have it, we come to a volume calculation case. You're going to see it in the demo. And then we put in our contacts. And we move on to put in our net to gross porosity. Remember, we've created a net to gross model, porosity model. And then we move on to put in our saturation model. And we go ahead and run it, do our calculation. So at the end of the day, like I said, all of the hassle we're going through is to arrive here. That is why we had to do our fascist model, we had to do our porosity, net to gross, saturation. Once we get this static model, then we run it, and once we're okay with it, we ship it to Loai and his team, the Reservoir guys, to continue with the studies. Okay, so basically, this is the entire workflow for the process. Okay, now I would want to share my screen again to show you from Petrel itself, what that also looks like. I don't know if there is any question on what I've presented, you can ask. But I'm moving on to the Petrel screen to show you the process. Okay. All right. I guess there is no question. No. Yeah, Mark.
Yeah, so my question was the output from the ML assisted from the fault and also the horizon. When you get the output, do you have to work on it? Like, what I mean is that how do I know that, okay, this output is really representative, probably in characterizing the subsurface?
Yeah. So with the output, right, you give it your labels, okay? You give it a label. Let me just share my screen so you look at it. I've not run anything now, but then I'll just show you what the process looks like. Okay. You can see my Petrel screen, right?
Yes.
Okay. So with a seismic interpretation, ML seismic interpretation, you come here. Let's say you want to do a fault prediction, right? You come here, you go to probably 3 pre-trained or user pre-trained. Now it picks your seismic for you, but you have to tell it what it should see to know. So you are like the driver. You are going to tell it, okay, so this is a fault and this is a fault. Okay. So you're going to have to pick just a few inlines or cross lines, just a few inlines or cross lines, 2 or 3 inlines or cross lines, and feed it here. Okay. And when you're picking, you're going to pick anything you see as a fault. Okay. It's a convolutional neural network. So and it's a user train. So anything you see as a fault, that is what you are going to pick and put it here. And then once you run it, it's going to output the similar things it sees that you have given it. Well, it's going to just output them and give it to you. It's just like the way driverless cars, right? Just like the way those ones also work. They work in a similar manner. We train the model to tell it, okay, there's a human being, there's this, there's that, there's that. So when it's driving on its own, it's able to decipher between the two. And it's the same thing. You, the geologist, give it what you want to see, what you are telling it as a fault, and then you just run it and it picks the rest for you. So the idea is you don't have to go ahead and be picking every inline or cross line, right? Now that work has been cut short for you, so you have the time to do other things. So yes, it does mimic the characterization of your horizons and your faults.
Okay.
And
Okay, thank you.
yeah.
That means user judgment also equally is very important.
Yeah. It is. Mark from Petroleum Commission, right?
Yes, please.
Ah, nice. Okay. If you want, I can share my email. If you want to have a demo, we can arrange that.
Okay. Thank you.
Yeah.
Wonderful.
Yeah. Michael.
Okay, say thank you very much for the opportunity. I want to ask. This whole process is quite technical, so I wanted to know how you can be conversant with this process, like very conversant with it, like how you're just flowing without any.
Yeah. It's just like riding a bicycle, right? Or skating. You have to practice. So, and you have to know the theory behind it, right? That is why I started off with the theory. So, you have to just connect the theory to what is happening in the software. So I'm going to go through the process quite smooth. You're going to see that it's not a hassle. It's not something you cannot learn. Okay. It's not too difficult. It's just straightforward. But the most important part is that you have to know what is happening behind the scenes. Okay. So, Michael, I'm going to go through the process now and
Okay.
just have a look at it. Okay. It's not something difficult. I've already run a static model. And I called it structural grid SPE. So what I'm going to do is just take you through looking at the time, will not be able to, I cannot run everything. So I'm just going to take you through the process so that you can see it. But I just ran one not too long ago just to show it to you. So like I was saying, there are different methods for the structural model, okay? But when you want to build your structural model, you do have the corner point grading, which is this one, corner point grading. And you do have the structural framework. That is, if you're building a model that has faults in it, you're going to take a model that has faults in it because that is more complex. So we do have structural framework. And so if you want to build a structural framework, you just toggle on this structural framework, and then you run it, whether in depth or time, depending on what your input data is. Most of the time, you do run it in depth, okay? When you run it in depth, you're going to have this created for you, and it's going to have the depth associated to it, okay? This is just an empty shell. It's an empty shell, like a housing, where you create your fault model, your fault framework. You see the way Petrel, one thing that is very interesting about Petrel is that, which makes it easier, Michael, for you to always follow, is that it arranges it in sequential order. What you have to do in sequential order. That's what I was saying. It's not difficult. You just have to understand the theory behind it. So we started off with structural framework, and then we're moving to fault framework. You see, that's the next thing we're moving to. So you click on your fault framework. This is where you want to build your fault framework. Okay, it's going to help you build your fault model. So in here, you want to put in your faults. remember when we run the ML fault interpretation, it spit out some faults, predicted faults, and interpreted fault for us. So you want to put in your faults over here, and it's going to pick them for you. Here I have so many faults here, and it's going to pick them. And one thing that is interesting about this is every fault has a relationship. That's if it's a complex fault, they will have relationships. Some will be truncating the other, others, I'll show it to you. Others will be joining others and merging and all of that. So when you put in your faults, the fault framework picks up that relationship for you. All you have to do is QC it and make sure that you are telling it it's seeing the right relationship. Then all you have to do is just click on apply. Once you click on apply, this is what happens. Okay, it builds this fault framework for you. Let me hide this and show you the fault framework. Okay, so this is a complex faulting system. You can see that there are some that are truncating. All of these sites are truncating. So when you're doing it in corner point grading, you, the user, have to go through it painstakingly and make sure you truncate them well and connect them well. But then with the fault framework, it does it quite automatically for you. You just have to QC it and make sure that the right relationship are captured and the truncation is done well for you. Okay. Now, when you're done with this, you can go ahead and do horizon cleanup. But most of the time, the reason why we do horizon cleanup is that when you're picking your fault, right, your horizon, you always have to leave the space near the faults. Okay, because if, say, let me show you something. Okay, so you see there is a horizon here. All right, and because of this faulting system, you see that there is this part of the horizon is shifted up, this one is going down. You have to maintain that space for the fault, where the fault is. You have to maintain that space when you're picking it on the seismic. Okay, if you don't do that, then you have to come back here and run a horizon cleanup so that it can clean up that space for you. You can clean up that space for you, and then so when you run your horizon modeling, you don't get errors. So if you don't clean it up and you run your horizon modeling, you realize that this displacement is not going to be captured well. Yeah, you're going to have a different thing altogether. Right. So that is it. We've already done that, so we are not going to do this. So we just move on to the model boundary. When you click on the model boundary, this is what comes up. Once your fault framework is activated, it picks it up for you. And then what it's going to do, it's going to, you can generate from the selected faults. So the model boundary, this is how it looks like. Okay, let me put this here and just show you. Yeah. Okay, yeah. Okay. So this is how your model boundary looks like. Okay, it's kind of drawing a boundary around your fault framework. All right, it's drawing a boundary around your fault framework to help you. So it's going to help you constrain the various things you're going to do in the next steps. You can define your model boundary with a polygon. I can draw a polygon around this and put it here so that it defines the boundary of my reservoir. So you can use this as your area of interest and just define a polygon there. All right. So once you're done with this one, okay, you can go ahead and then run model construction. You see, it's just one after the other, one after the other. You go ahead and run a model construction. When you run the model construction, this comes up for you. Once remember your fault framework is highlighted, that is, it's activated. So it picks it up for you, and then it picks up the various horizons that are within your fault framework. Now, this is why this is important, okay? For the horizons, you need to create it in order to get different zones within your model. All right, within your model. You need to get different zones within your model. Okay, that's why you need to get your horizons, and then you have to also put in your various wall markers, the tops over here. Okay, then all you have to do is just click on apply. That will also run for you. And that model construction is going to spit out this. So so that model construction is going to build on this and build the different model for you with the different horizons like this. Okay. But this is not the final result you want. Okay, this is just a model that has been created for you. Okay, your final results, once again, remember, we've said that it depends on, you have to know what your model is for. What is the end goal? Okay, so once you're done with model construction, you just have to run model refinement. You can run it, it's going to just increase, run the resolution and run a smoothing for you. Just click on apply, it runs it, smoothens everything for you. Now, this is where you have to make the decision, whether you're going to do a depot space or a structural grid. Okay, here you have to talk to Loi, RE person, and ask, okay, Loi, do you need a model to run a reservoir simulation? Oh, yes, I do. Then you go ahead and run a structural grid, a stair step. You see the symbol, stair step. This makes it easier for Loi to also run his reservoir simulation work. Depot space is for detailed geological work. Okay, so here, for the sake of this demo, we went ahead to run stair step grid. Okay, so you're going to see here. So we went ahead, ran a stair step grid. I've already run one, so you're going to see, I ran actually two. So there's the one that is here. So you're going to see this depot space is going to pick up the structure. Remember, we've already created a model construction. So it's going to pick up the model we've constructed. Automatically, it's going to pick the IJ directions, the length, so the spaces. And then it's going to pick up the various horizons that we have in the system. The number of layers, you have to define the number of layers, okay? The number of layers is dependent on how complex you want your model to be based on individual zones. Maybe in a particular zone, you're seeing that you have a lot of sands that you want it to be captured well, so you put more layers there, okay? But remember, the more layers you put in, the more complex your model becomes, and the longer it's going to take to run, depending on your laptop or your workstation. So once we are done running this, you see that you're going to have this created, okay? And you see the shape. It's a stair, it's like a stairs. So stair step. You see the shape here, which tells you that it's a stair step. Now, all that we've done, okay, let me close this and show you this. All that we've done, okay, all that we've done is to create that volume. Remember the stop tank oil in place formula? We are creating the volume, area times height. That is what we've done. We've not done porosity, we've not done fascias, we've not done any other thing. Now that we've created it up to here, you see, we went from here up to here, and that created our model for us. Okay. Now we need to move on to the next one, which is property modeling. You see, it's sequential. So we move on to property modeling. I'm going to go through the property modeling process. It's quite simple as well. All you have to do is to understand what you want and why you're doing what you're doing. Okay. The first thing you want to do in property modeling, remember, you've created this space. It's a hollow space. There's nothing in there. Okay. You've not put any property there. It's just a volume. Now, how do you put your properties in there? You have wells that are penetrating most parts of this reservoir. Okay. So if I toggle on my wells, you're going to see that there are several wells. Yeah. Sorry. Yeah, it's kind of showing, but it's small. So there are several wells that will penetrate. Sorry, there's a well filter. Yeah, there's it. Okay. Yeah, so there are several wells that are penetrating this model. Okay. Now I want to populate the properties within the model based on the well locations. Okay, so I'll come here first. Once again, we are starting from the left to the right. So we start from the left, well log upscaling, we click on it. What well log upscaling is doing is that it's going to assign the log values to the individual wells. Remember the wells that we saw here? Once those wells have that particular log, it's going to assign that log value to the wells. Okay. The first thing we want to do is to run fascist upscale. So why do we have to run fascist upscale? Once again, the fascist is what carries our porosity and our permeability. So that's the first thing we have to run. Okay. And most of the time, the averaging method we use is there is a reason behind that. It's, yeah, the default one, but there is a reason behind that. And I could go into it, but our time, it's a bit far spent. But the most of is the averaging method we mostly use by default. And then you select the wells that you need. Here we're going to choose every well. So once you run that, you're going to have this property populated. And that's going to create this thing for you, fascist log. And you're going to see a U beside it. The U means that it's upscaled. And upscale means that we've brought it from the wells, the log from the wells, and we've brought it into the model. Okay. We've brought it into the model. All right. So I've already run a model for this, so you're not going to see it. Let me run another upscale for you to see how it looks like. Okay. All right. So this upscale, let me close this. All right. So you see, these are all well locations, and these well locations have that particular log. And so it defines the log over there for you. Now, once you're done with your fascist model, you want to upscale all the logs that you need: porosity, permeability, if you have it, saturation, if you have the log, net to gross, if you have the log. So I've gone ahead to run everything. You can see all of them here. It's the same process. You just select the log you want from here. Okay, you come to create new, you select the particular log. If it's permeability, you select permeability. Petrol itself is going to give you the best averaging method to use for that particular log. So you just have to select that and then apply. And that is going to create the different upscaled logs for you. Okay. Now, that upscaled log, all right, it's you're going to have it here. Our time is moving on, so I'm going to move directly to the property modeling process. But before you move to property modeling process, you must always have to do your data analysis. The reason why we do data analysis is that you see the wells that have been upscaled here. There is no property in between those wells. There is no property in between them, all right? So how do we put property in between them? This is where our geostatistical knowledge we are learning in school comes in, okay? We want to populate from one well to another, from one well to another. And that is where this thing plays a part. So we can come here and go through this, go through the variogram. We can also go through proportions just to constrain that distribution that is happening from one well to the next. Okay, we've already done this on the back end. So once you've done this, you just go ahead to your fascist model and then run the fascist model. And you're going to have, so yeah, there's the new upscale I upscaled. This is the model created. I just ran this without using any of the data analysis, just to show you the results. So you have to run it for every zone, actually. You can also constrain it with any other thing you want to constrain it with, condition it. But you have to run it for every other zone. And once you're done running that, it's going to give you your fascist model looking like this. This is based on the data that we are using. So it's going to give you your fascist model. And you're going to go through the same process for your porosity, your permeability, your net to gross. That's if you want to model your net to gross, your permeability, your saturation. You're going to go through the same process. You're going to have to do it for every zone, and then you run it, and you're going to have your models created nicely for you here. Okay. Now, when you're done with all of this, remember our end goal is to calculate volumes. Okay. When you're done with all of this, you click on volume and you come to, this was showed by Loai during his presentation. You have to come here, put in your contacts. Okay. Yeah, so you have to create a contact first. You come to the contacts, create the contacts, you define the very contacts that you want to define. Then you put them here. And when you come to general, once you've selected the right static model, it picks up the porosity for you. There's only one porosity in there. And then it also picks up the water saturation for you. It also picks up the water saturation and the net to gross. There was, with this particular data, there was a problem with the net to gross. So I decided to use value for this net to gross. But you can also use a model. You can just run it with a model. Yeah. So once you do that, okay, you can come to the settings, show what you want to report on, exactly what you want to report on. And then when you run it, okay, I'm just going to run it simply like this. Okay. And it's going to generate what I told it to generate. Okay. I asked it to generate all of these. Remember, these are the very things you need for that STOIP calculation that you learn in school. You need your area and height, which is the net volume or bulk volume, but this time around times net to gross, which gives you net volume, times the porosity, which gives you your pore volume, times the saturation, which gives you your hydrocarbon pore volume. Okay, you divide your BO by that and you get your oil initially in place. The same thing goes for the gas initially in place. All right. And this gives you for everything based on what you've told it to give you, it gives you for everything. All right. So that is how we go ahead to create a static model. Okay. Quickly, I want to show you in cases where you don't have property data like these. You don't have any log, any property model. You've not run a property model. Okay. You've not run a property model. In cases like that, what do? You don't always have to build a model before you can get your volumes. All right. So I'm going to quickly show you another option that is in Petrol here, and that is the map-based calculation. Okay. You come to the seismic interpretation tab, you go to depth group, and then you click on map-based calculation. So what map-based calculation does is it circumvents the whole need for properties. Okay, so if you're doing your project, you've not done property modeling before, you find it difficult, you can go ahead and run, speak to your supervisor, you can go ahead and run a map-based calculation. That is also going to give you your volumes. All right. What you need in a map-based calculation is define the contact you have, define the net to gross and porosity, define what you want to calculate for oil or gas or both of them. In this case, both of them. I run an SP case here, this one. In this case, both of them. And you can put in as many zones as you want. So if you put in a zone, you can just click on this and it comes up for you. Okay, let's say you want to put in a base and you want to hide the last zone. So you can just hide the last zone and put in a base for that particular zone you want to calculate. The top tablet to maybe the tablet 2 to tablet 1. You just put the base here, right? In this case, we used an isocore. So we delete this, and then the isocore comes in. The isocore is a thickness between two markers. So the wall tops, tablet 2, tablet 1, we calculated a thickness. So that thickness is the zone, all right? and we put in the contact for the gas, the net to gross, average net to gross value, average porosity value. These values you can get if you get a petrochemical data, you can get a net to gross from there. And then we put in our saturation, same with the gas saturation as well. This seems like a volatile oil, if I may say, because it has some oil saturation within the gas as well. Yeah. So you have your water saturation here. Your BO has also been defined. Your BG has also been defined. Since we're calculating this initially in place, stock tank oil initially in place, we will make the recovery 1. But in a case where you've already produced and you want to run a straight calculation on what is available now, you can make the recovery that current percentage that you have, and it's going to calculate the volumes for you as well. But just that it's going to label them as initially in place. Okay. So here too, you can come here and generate maps. Maybe you want to generate your hydrocarbon power volume map. You want to generate your stock tank oil in place map to see the distribution of your oil within your reservoir area. You can do that as well. And then when you come here you can constrain it within, you can constrain the calculation also within a particular area of interest. You can do so over here as well. And within the outputs, the same report settings are here. You can go ahead and then put in the volumes that you want to run. What you want to see, you put the volumes there, and then you run them. And once you run it, that is also going to generate. So when I came here, I told it, okay, yeah, to make report. So what I'll do is I'm going to uncheck this. If you check on output intermediate results, what it's going to do is it's going to output the model. It's going to output a static model for you, right? Okay, let me create a new one and just say that SP case 2. Okay, so what I'm going to do is click on apply. Oh yeah. Okay. So I'm going to click on apply. You see, when you click on apply, before running, it gives you a question mark. Then when you run it, it generates everything for you. I told it to generate some maps, right? So, and I also told it to generate those intermediate, this one, the intermediate results. So it's going to put it in a folder called map-based volumes in your models pane, and you're going to see it here. There's the current one that has been run. I've run several of them, but there's the current one. It gives you the timestamp. And within it, you're going to see your skeleton, just like we did for the static model. But here is a bit different. You're going to see your skeleton. You're going to see the different horizons that you put in. You're also going to have some properties, but these properties are going to be values. No, they are not going to vary. There is not going to be heterogeneity within the property because remember, we just defined a value for them. So they are going to be constant throughout, the same as porosity, saturation, net gross, and all of that because we define a value for that. Okay. So within the input pane, I told it to output some results for me as well. And you're going to see those results here within the input pane. Okay. When I click on this, let me hide this. Okay. I get to see my oil initially in place map, and I can put it in a map window and use it for any results I want to display. Okay. So basically, at the end of the day, remember the basic truth is that the entire G&G part of our reservoir simulation work, if your desire is to calculate volumes, it's all working on that very formula. The stock tank initially in place formula. That is basically what it's doing. There's one thing I forgot to mention when it comes to property modeling. There is also an ML solution for property modeling, the whole process we went through in the property modeling workflow when we came here. There is also an ML solution for that, which is called Ember. And here you have to just give it certain parameters, training target, some features that you want it to show, maybe some amplitude, some volume amplitude extractions, volume attributes or surface attributes, and then you bring it there so that it helps it to be able to predict what the porosity and your permeability looks like. Yeah. So that is that one too. That is the entire workflow for your structural model. You can run sensitivity and uncertainty analysis on it as well, but most of the time we give it to the RE, that's Loa and his team, and they run it, and they give us, they also run the sensitivity and uncertainty as well. Yeah. So that is it. That is everything. I hope I did not bore you too much and it wasn't too much of information. I hope you can relate it to what you're studying in school or what you're working with in your workplaces as well. Yeah. And if you want to connect, you can always connect with me on LinkedIn. Just search for my name, Alexander Mensah. You can always connect with me on LinkedIn. And if you have any other question, just shoot your question, and I'll try my best to answer it as best as I can. Okay, over to you, Osei.
Thank you very much, Mr. Mensah. Thank you for such a wonderful presentation. Please, if anyone has a question, you can use the raise hand feature to raise your hands and you'll be called. You can also put your question in the chat box and we'll read it for you. So we are in the question and answer stage right now. So please drop your questions.
Yes, Michael.
Yeah, sorry. You mentioned that the uncertainty analysis usually will be done by the RE, but what about those static properties that are also?
Yeah. You can run sensitivity and uncertainty on those properties as well. You can do it in map-based volume calculation. You can do it in static volume calculation as well. Yeah.
Right.
Yeah.
Thank you.
Yeah, you define it the same way that the RE is going to define it. You just put a dollar sign on what the variable you want to define. You put a dollar sign on it, and then you tell it, okay, this is the range I want it to be. Maybe your contact depth, you want to shift it up or down. You just tell it the ranges and run. Yeah.
Hey, thanks.
Yeah. Okay.
So Michael, you can speak.
Yes, Alex, please, I wanted to ask, as you were saying that we need to get the theory behind it, I wanted to know if maybe you can share with us some literature that will get so that we can enhance our knowledge on it. And also, myself, I have the Petrol app, but yours is quite advanced. I wanted to know how maybe you got yours, how you downloaded yours. Thank you.
Yeah, you for literature or videos on it, you have to. There are so many videos on YouTube. Actually, there's this professor called Michael Blunt. I think he's in London, one of the London schools. I've forgotten the name of the school. He's very good. That he does a lot of reservoir engineering. There are also some, if you're a geologist, there are also some very good geological engineering YouTube channels. So you can learn a lot from those areas. You can just hit me a message on LinkedIn. I'll find them and give them to you. And on your second question, how you can get, I think you have to go through your university if you're still in school. If you are not in school and you're working, you have to go through probably your management, let them send us an email. And yeah.
Okay, thank you.
Please, does anyone else have a question?
Oh, hey. Dr. Thompson. Is that Dr. Thompson?
Yeah, Alex, how are you?
I'm good. I'm good. How about you
It's
too?
good. You are now the chairman of Reservoir Simulation.
We try.
That's good. That's good. Okay,
Yeah.
that's nice. So, with your presentation, how do our students also get access to the tool and also use it?
You mean the Petrol 2?
Yeah.
I think it has
Yeah, you
to,
suggested they can watch videos. Yes, there are a lot of videos on YouTube, but
yeah,
to
there
go
are a
and
lot
watch
of
the video
videos.
without having the tool itself to practice, it do not
Yeah,
make so much meaning.
yeah. Yeah. There are a lot of videos on it. I think this very session is also being recorded, so that is also going to help, and it's going to be on the SVE YouTube page. So that is also going to help a lot. And there are Dr. Thompson, I can send you some links so you can share with the students as well.
Okay, thank you very much. Thank you.
All right, sir. Yeah.
Thank you for the great work. Yeah.
Thank you, sir. Mark.
As for this one is a comment. I want to speak for UMAT. If probably SLB doesn't have a trial license for both Eclipse, Intercept, and Eclipse, probably you can help UMAT with some trial license so that the student can use it for their research work. So that we want to advise how they can take it up if the process is involved in, so that it can reduce the learning curve right from school to the industry. Thank you.
That's good. That's laudable, and it's true. I think UMass should have a package like that. UMass should have a package like that. I'll cross-check again, but the last time I quite remember UMass did have some SLB tools, the Petrol Eclipse and all of that. Yeah.
Okay. Maybe Dr. Thompson and his team will take it up.
Yeah,
Probably.
Alex, I think those things have expired, so maybe we need to renew it also. Yeah.
Yeah. Then probably you want
Okay.
to take it up and then probably follow through. All
Yeah.
right. Thanks.
Okay.
And so Alex, please, we those who have completed, I completed the math last year. Please, how can we get access to it?
Yeah, for individuals, you have to purchase a license. For individuals, you have to purchase a license. You can chat me up. I'll chat with you on the side on how that is also done. For companies as well, you have to purchase license package. That one too, you can chat me up. I'll chat with you and let you know how that one is also done.
Okay.
Yeah.
Okay, thank you very much to Doc and then your other colleague for the insightful presentation. We appreciate it.
Thank you, Mark. And thank you to SP for the opportunity. And we'll relay our response to the ISLB team as well. Yeah, thank you.
Thank you very much, Alex and Laura. Thank you very much for making the time to facilitate the